Today, we're diving into one of the most incredible engineering proposals I have ever seen. We're talking about a spacecraft that's designed to operate all by itself for 20 years in deep space. We're going to go straight to the source, the actual grant proposal, to figure out how on Earth it works, how you'd even build it, and yeah, what it would cost.
Okay, let's get right into it. What you're looking at here, well, it's not just a machine. It's designed to be a self-sustaining system, an explorer that can survive on its own for decades, totally cut off from human help. So we're going to break this whole proposal down and see exactly how you'd build a machine like this, piece by piece.
And really, that brings us to the huge question at the heart of this entire project. What if a machine could essentially live forever out there in the void? What if our creations could outlast us in the most hostile environment we know of? I mean, what kind of a future does that even unlock?
So, to get our heads around this massive idea, here's our plan. First, we'll look at the big problem this thing is trying to solve. Then, we'll get into the radical solution, the ship that literally heals itself. We'll actually assemble the Explorer system by system, then we'll tally up that jaw-dropping price tag, and finally, we'll ask, why is it all worth it?
Right, so before we can really appreciate the solution, we have to understand the problem. Why if we kind of hit a wall when it comes to exploring really deep space? Well, it turns out there's some pretty fundamental limits to what our current spacecraft can do.
The proposal itself points out three huge barriers. First off, systems just break down over long missions. Things wear out. Second, our ships are completely dependent on Earth. If something goes wrong, they need us for repairs and resupply, which is just impossible on an interstellar journey. And third, the risk to human life on these missions that last for decades, it's just way too high. The way we do it now just isn't built for the long haul.
So if you want to solve a problem that big, you need a seriously radical new idea. The solution they came up with isn't just a better spacecraft, it's a totally different kind of thing. It's something that doesn't just put up with space, it actually adapts to it.
And this quote from the proposal, this just nails it. This is the big mental leap. We have to stop thinking about ships as these static tools that just wear out over time. The whole vision here is to build something that's more like a living organism. Something that can check its own vitals, fix itself, and just keep going.
And this timeline shows you this isn't some sci-fi dream. It's a meticulously planned out project. But the really mind-blowing part is that last phase. 20 years of autonomous operation and evolution. The ship isn't just running a program, it's designed to learn and get better all on its own, long after it's left us behind.
Okay, now for my favorite part, the build. We're going to virtually put this incredible machine together. Think of it like we're opening up the most complex, most expensive, and most important construction kit in human history.
Every great build starts with a solid frame, right? So here it is. This is the core structure, the pressure hull. And get this, the proposal even details self-healing panels that can automatically patch tiny holes from micrometeoroids. This is the skeleton holding the whole thing together.
Of course, a skeleton isn't much use without a way to move or power itself. So next up, we add the heart and the muscles. These are the advanced propulsion systems, these massive radiators to get rid of heat, and of course, those giant solar arrays. This is what gives the ship the energy to live and work for decades on end.
And now let's connect everything with the nervous system. These are all the avionics and control modules. You can think of them as all the wires and processors that let all the different parts talk to each other, carrying commands and signals all over the ship so it acts as one cohesive unit.
Okay, before we install the brain, we need to understand this key concept, the digital twin. It's an idea that's already being used in things like Formula One and designing jet engines. Imagine a perfect one-to-one virtual copy of the entire spacecraft that lives inside its computers. It's constantly being updated by millions of sensors, letting the AI predict that a part is going to fail months or even years before it actually does.
And right here, this is the hardware that makes that magic possible. These are the AI compute stacks, the physical home for that digital twin. This is the ship's consciousness, its ability to see the future. This is what turns it from a simple machine that just reacts into a thinking system that can predict what's coming.
So the AI can predict a problem, but who actually fixes it? Meet the crew, a whole fleet of autonomous humanoid robots. They are basically the ship's immune system, its white blood cells. When the digital twin predicts a failure, the AI sends one of these robots out to swap a part, weld a seam, or even fix another robot, long before anything catastrophic can happen.
And there you have it. Skeleton, heart, nerves, brain, and crew all assembled.
A complete, self-sustaining explorer ready to head out for 20 years into the great unknown. It's just incredible to see how all those modular pieces come together to create this. All right, so building a machine that can basically live on its own for 2 decades is one thing, but paying for it? That is a whole other conversation. So let's talk about the absolutely staggering cost of this kind of technological immortality. This slide just lays it all out. Seriously, just take a second and look at the numbers next to each of the systems we just put together. The scale is just, it's unbelievable. You have individual components that cost hundreds of millions of dollars. But let's get to the bottom line. According to the proposal, the total estimated build cost comes in at just over $10 billion. $10 billion. That's the initial price tag just to get this self-healing ship built and off the ground.
But wait, the spending doesn't stop at launch. Not even close. The 20-year operating cost is estimated at another $6.8 billion. That's the budget to keep the lights on, you know? Paying for the deep space network to talk to it, for the mission control teams back on Earth who are constantly updating its software and analyzing all that amazing science it's sending back.
So where does most of that initial $10 billion actually go? Well, the single biggest expense is propulsion and power at over $1.1 billion. No surprise there. Right behind that is the ship's brain, the AI and digital twin, costing $720 million. And then the specialized skeleton, the structural and hull systems, come in third at $660 million. So that brings the grand total to somewhere around $17 billion. The cost is, well, it's astronomical. So you have to ask, what's the payoff? Why would we even think about an investment on this scale?
Well, the potential impact is nothing short of transformational. Scientifically, it opens up the entire solar system and even beyond to long-term close-up study. Technologically, it would create a whole new gold standard for robotics and AI. And maybe most importantly, from a societal standpoint, it's a game changer because it takes human astronauts out of harm's way on the most dangerous, longest missions. And of course, a project this big, this bold, it inspires a whole generation to dream bigger.
And that really just leaves us with one final thought to chew on. This whole proposal isn't really about building a better spacecraft. It's a proof of concept for persistence, for survival. If a machine can maintain itself for decades in the absolute emptiness of space, what does that make possible for our future out there, among the stars? What doors does that truly open?